So before break, we did MA2 and AR2 model. Any questions before we go to the next example? I'm sorry, we are in class in progress. Okay, any questions? All right. So this example is about stock price, closing price, 65 daily closing price. Okay. So I'm going to open up the data first. So this is example 9.3. Oh. Okay. So this is the daily closing price for our stock. So 65 days. Sorry for the background noise. It's a small place, you know, you have family members, okay? Okay, so what are we going to do with this data? So of course, we are going to set up a model and then do forecast, okay? So for this one, we are going to fetch, so before we use the model, let's explore the data pattern, okay? Let's explore data pattern. So let's create a chart, okay? So go to the SPSS. So I'm going to open the data file 9.3. So originally there is nothing, it is just the data. So I'm going to maybe, I will delete some data from all over again. Okay, so this is the original data, daily closing. Okay, stock market, daily close price. This is the time, this is the daily data. Okay, every day. Okay, so now let's explore this data pattern first by create a chart. So go to Analyze, Forecasting, Sequence Chart. Variable is the index. And then click OK button. You see, this is the chart. Okay, so I'm going to copy this one into OneNote so that I can analyze. Try to find a space. So obviously, this data is trending up. It is not a stationary data. Okay, not a stationary data. Because it is not a stationary data, so that's the reason we want to try to do the difference first. Okay, we want to do difference first, means we want to use Y2 minus Y1, Y3 minus Y2, Y4 minus Y3, etc., etc. Generally speaking, we want to do YT minus YT minus 1. Okay, and this differencing in ARIMA model. Remember, we have a P, D, and then Q. Okay.
Professor.
So D in this case equal to 1. Yes, questions?
Could you show again how you got the graph, please?
Oh, sure. So to get the graph, there are many ways to do it. One way, you go to Analyze, Forecasting, Sequence Chart. sequence chart, and then you move the variable into the variables box. Then you click OK button. That's it.
Thank you.
You're welcome. Any other questions? And the other way to create this chart, you use chart builder. I will show you here. Go to graph, and then go to chart builder and click OK button. So you want to create a line chart, click line chart. Then click this, move and drag it here. So after that, time is your X, original data is your Y, and then you click OK button. So you can get the same graph, different method, see? Okay, thank you for your question. Other questions? Okay, so now from the graph, we know the data is trending up. We need to do the difference. Okay, so that it will become stationary data. Okay, this is the one observation. And the other observation, we need to create an autocorrelation to see if data are correlated to each other or not. So go to Analyze, Forecasting, then Autocorrelation. Remember, we did this many times in previous chapter, chapter 4, chapter 5, etc. So autocorrelation, and move indexes to variables. And then click OK button. So this is the autocorrelation. Obviously, it has significant autocorrelation. See, like 1 correlate to like 2, etc. As long as the graph above the limit, you see the blank line, those are the upper and lower confidence limit. You have these autocorrelation problems. Okay, you have these autocorrelation problems. All right. So now let's take a look at the difference. How about if we check out the difference, what would happen? Okay. So this is original data. Okay. So we go Analyze, Forecasting, and then autocorrelation. This time we need the difference. Okay. So we need YT minus 1. We want the difference. Okay. And then we click OK button. So after you do difference, wow, you see the autocorrelation problem disappeared. All the data remain the lower limit and upper limit. Okay, this is the autocorrelation, and the partial autocorrelation is also within the limit. So that means we need to do the difference for the original data. Do the difference for the original data. Okay. So any questions about our decision based on the chart of the data? So first decision, we need to do the difference because it is trending up. This is reason 1. Reason 2, data are highly correlated to each other. Highly correlated to each other. Okay. So that is the decision we have made. Okay. So after you made that decision, so what? Okay, we know we want to do difference. We know we want to do the difference. Okay, and then you can propose a model. You can propose a model. The first model we proposed, we want to use ARIMA 1, 1, 0. Let's start with 0. 0 means moving average, non-moving average, non-moving average. And this 1 in the middle means difference. Difference between YT and YT minus 1. Okay, and this one means AR1. What does AR1 mean? It means YT related to YT minus 1. Okay, remember there's a constant phi 0, then phi 1. That means 1 YT related to YT minus 1. So any questions about ARIMA 1, 1, 0? And this 0 means non-moving average. Okay, once we understand ARIMA 110, we can use SPSS to fit this model. Okay, to fit this model. So go to the data. Analyze, forecasting, create traditional models. Try to, okay. Did I click record button? Yes, it is recorded. Analyze, forecasting, create traditional model. Quick, do I need to define date? No. So dependent variable is an index. I will use ARIMA. Criteria, I try 1, 1, 1, 0. I want to try this model. Okay, so difference, non-moving average. Okay, click continue. And then statistic, parameter estimate, display forecast. Okay, so this data we have 65 cases. We want to forecast 66. 66. Plot. We want residual autocorrelation, residual partial autocorrelation. Save. Predicted value. Options. We want to forecast for 66. Time period 66. Okay. All right, then you click OK button. Okay, and this is our output. We use ARIMA 110 model. And this is the statistics about model fit. Okay, mean value, minimum, maximum, etc. Okay. The model statistics, we have this Yang box Q, LBQ. We have this statistic. Okay, looks like pretty good model. Over the parameters, we have a constant. We have AR like 1. Okay, so that is our model. Okay, our model, you need this, these numbers. So our prediction based on this model, the prediction for time period 66 is 289.94. Okay. So I want to point out that this constant 1.03 I want to explain here. So we get the output. So you have to do something about this number, this constant, to get the real constant. Okay. So you need to, what you need to do, you need to use this number 1.035 times bracket 1 minus the coefficient for one time lag, 1 minus 0.28. You need to do this calculation. And this result is 0.7452. Okay. After you get this number, you can write down the equation. Okay, so the equation would be, what is the equation here? Remember, we use the difference for AR1 model. Okay, so because we are using difference, so we are saying YT minus YT minus 1, this is the difference. This should be equal to a constant phase plus a coefficient phi1 times a one time lag. So it should be YT minus 1 minus YT minus 2, and then plus an error term epsilon t. Okay, so this equation actually, it is a take form. The general equation should be YT equal to phi 0 plus phi 1 YT minus 1 plus epsilon t. This is general equation. Because we are taking the difference, remember? So instead of whatever you say YT, you have to use YT minus 1. Whenever you say YT minus 1, you have to do difference. YT minus 1 minus T minus 2. You have to do this, okay? And after this, so this number 0.7452, this is our phase 0. So final exam, I will give you this output from SPSS. I will write down the equation. Don't you, if you directly use 1.035, you are wrong. You have to do calculation. Use 1.035 times 1 minus one time lag for AR. The result is 0.7452. This is your phase 0. This is your phase 0. Okay, this is the way SPSS dealing with the constant. Our textbook used mini tab. If you use mini tab, you directly get 0.7452. If you use mini tab, okay. And if you are using R dealing with the constant similar to SPSS, you have to do this calculation, 1.035 times 1 minus 0.28. As you can see, different software using a little bit techniques to dealing with the parameters. Okay. All right. So this is our model. Once you plug in phi 0, 0.7452. This number is phi 1, 0.280. But 1.035 is not phase zero. Okay. You have to calculate phase zero based on the output from SPSS. Okay. Any questions? And the residue plot as well as the partial residue plot looks good because they are within the limit. They are within the limit. All right.
Professor, sorry, can you just write down what the equation would be based on that, based on the calculation that you made?
Thank you so much. So yt minus 1 equal to 0.7452 plus 0.28 times yt minus 1, yt minus 2. When you do actually forecast, the epsilon t is 0. When you do the forecast, epsilon t is 0. So that term is gone. So for example, let's do the forecast. Let's forecast 66. Okay, let's do 66. So if you want to do y66, so you do minus y, t minus 1 becomes 65, right? So equal to 0.7452 plus 0.28. T minus 1 becomes 65. T minus 2 becomes 64. Is that clear? So continue. We want to forecast. Forecast means hot. So we know 65. What is the value for 65? If you check the data, it is 288.57 equal to 0.7452 plus 0.28. Then y65 is 288.57 minus y64. Y64, go back to original data. It is 286.33. Okay. And did you see you one step further, you will get y66 hot. Okay. Just do the arithmetics, do the addition, subtractions. Okay. And you will get, my calculation shows I got 190.26. You can double check. Okay. So that is 66. Maybe this is a 23. Okay. All right. So that is how do we fit using the difference to fit ARIMA model? Okay. Any questions? And the computer also produced the forecast for us. If you scroll down, see, this is the forecast from SPSS. Okay, 289. My result got 290, maybe because of the rounding problem. Okay, so, or you can double check my calculation. Okay, I didn't double check. So anyway, there's just few decimal places difference. Okay, so any questions? Okay, this is a we select. So remember what is this? This is ARIMA. ARIMA 110. Okay, next we are going to propose another model. This is our next. So next we are going to propose ARIMA 011. 011. The first 0 means no autocorrelation. The one in the middle means difference. The one in the last means moving average. Remember, what does the moving average mean? Moving average means you relate YT with it is equal to mu minus omega 1 times so omega 1 times epsilon t minus 1. This is the moving average. Relate y value with the error term, the previous error term. This is MA1. Okay, some questions. Let me check the chart area. Okay, I don't see any new questions. Okay, now let's do ARIMA 0, 1, 1. So I'm going to delete. Okay, I can keep this later on. The result we are put here. Okay, so go to analyze, forecasting, create traditional models. Click OK button. Variables. ARIMA criteria. This time I want to select 0, 1, then 1. Okay. Click continue. And then statistics. Make sure check out parameters estimate. Display forecast. Plot. Residue. Autocorrelation functions, residue. Partial autocorrelation. Save. Forecast value. Option. Forecast for 66. Okay. And then click OK button. So this is the result. Okay. So once we get this result, the model is based on this number here, constant, and MA like 1. Okay. So I'm going to go here. So the model is based on constant. This constant is our mu. Okay, population mean. And this MA like 1 is our omega 1. Okay. So once, and remember we also have the difference. So the model should be, the general model is this one. Because we also did the difference. So now you have write down YT minus 1 to reflect the difference equal to mu minus omega 1 times epsilon t minus 1. This is our model. Okay. So to forecast for t equal to 66, you do y hat 66 minus y 65 equal to mu. Mu is 1. Not here. We are doing MA. Mu is equal to 1.038. 1.038, that is the mu. Omega is a negative 0.287. So minus negative equal to plus positive. minus negative equal to plus positive 0.287, okay? And then times epsilon t minus 1, we can use sample. Remember, the area for sample is E. The area for population is epsilon. So we can use the sample E65 estimate epsilon 65. Okay, so here we use E65. Okay, continue. So y hat 66 minus y65. What is y65? Y65 is 288.57, 1.038 plus 0.287 times E65. How do I find E65? Go back to your data. Okay, E65. So you use 288.57 minus 287.25. Okay. So this E, you get 1.52. So use 1.52. So times 1.52. Okay. And then you can get the forecast. Okay, my result, I get Y66 forecast. I got to 90.04, 044, something like that, 044. You can double check, okay? There may slight difference. Oh, what is the SPSS forecast? SPSS forecast. We got here 290.04, the same as my hand calculation. Oops. This is SPSS forecast here for 66. Okay. Any questions? Give me 1 second. Sorry for the background noise, guys. Actually not at my place, at my daughter's place, okay? Okay, so the residue correlation functions and the partial residue functions looks good. They're all within the limit. Okay. All right, so in this example, we proposed 2 models. So let me write down the summary. So in example 9.3, because the data is trending up, so this is the time, this is the index, closing price. We propose difference. Okay, so we proposed first of all ARIMA 110. Then we propose ARIMA 011. 2 models for this example. Any questions? All right. So next example, example 9.4. So in example 9.4, again, we are going to propose 2 models. One is MA2. MA2 is the same as ARIMA 002. AR1 is the same as ARIMA 100. We want to do two models for this example. Okay, so what is the data for 9.4? Let me see the data. So I'm going to point the data for 9.4 here. It is also available on Excel, this data file, okay? So I'm going to delete all of those because the original data is just this data, 75 of them. Okay, 75 of them. All right. Are you ready? Do two models. Okay, let's do ARIMA 002 first. ARIMA 002. So our objective is to get the model. Once you have the model, you can do the forecast, right? You can do the forecast. All right, so this is MA2. So go data. But before we do this model, we may want to explore data patterns. I got questions. How do we know when the constant is omega or phi? Omega or phi. Okay. So the question, how do we know the constant is omega or phi? Okay, let me clarify this question first. Okay, to clarify that question, good question, by the way, okay? When the constant is omega, it is omega, dealing with the MA. When we say omega, the other is phi, is dealing with AR, omega dealing with MA. Good question. Okay, so for example, the AR model, let's write down a few AR model. Okay, so let's write down AR1, AR2, AR3. Okay, so what is AR1? AR1 means YT related to YT minus 1. There is a coefficient phi 1. There is a constant phi 0. That is AR1. Okay. And then what is AR2? AR2 said YT related to YT minus 1, YT minus 2. How to relate constant phi 0 plus parameter phi 1 plus phi 2. So that is AR2. Each model has the epsilon t plus epsilon t. So AR3 said YT related to YT minus 1, YT minus 2, YT minus 3 plus an error term. How to relate a constant phi 0 plus phi 1 times YT minus 1, phi 2, phi 3. And in AR1, P is 1, AR2, P is 2, AR3, P equal to 3. Okay, so that is the AR. And for MA, let's write down MA1 and then MA2, MA3. When you have MA1, Q equal to 1, when you have MA2, Q equal to 2, MA3, Q equal to 3, what is MA looks like? MA looks like this, YT related to mean value, okay? And the error term for T minus 1. This time we use omega 1, okay? And plus an error term, epsilon T. So that is YT, that is MA1. What is MA2 looks like? It looks like this. So YT related to the error term for T minus 1, the error term for T minus 2, and the error term for T. Again, it is a mu, okay? Mean value plus, not plus, minus omega 1, minus omega 2, minus omega 3. This is the multiplication, omega. Omega is the coefficient, okay? And do not forget the error term, epsilon T. No, there is a, sorry, I made a mistake. There is no coefficient here. It is just epsilon T, okay? And then hope you can write down MA3 by yourself at this point, okay? MA3 by yourself. So let me write down YT related to error term for T minus 1, error term for T minus 2, error term for T minus 3. How to relate? Mu minus omega 1 times minus omega 2 times this one, minus omega 3 times this one, plus epsilon T. Okay. That is fantastic question. I cannot see your first name, but it is D. Okay. That's very good question. Okay.
Professor, I have a question here. So
yes.
For the MA, I think it's YT minus 1 equal, right?
For the MA,
Yeah, is that right?
for MA1, it is YT, not, it is this one. This is for MA1. What is your question, Benny?
Because when I saw your example before, what you did was YT minus 1
Okay,
equal to,
I got your point. Here, I'm talking about MA1. What you are talking about, what I talked before, okay? It is so MA1, it is the same as ARIMA 001. What you are talking about, what I did before was ARIMA 011. You see the difference between these two, between this and this, they are different. Okay, this one does not have difference. See this 0, and this one has a difference.
I see.
Good question, good observation. They are different. Okay, so if you ask me what is ARIMA 011 model looks like, this is the one we talked before in that example. I gave you detailed explanation somewhere here. No, it is just here. Yeah. Okay, the notes is here. See, this is ARIMA. Okay, with the difference. So you have to see if there's a this one here. See, I know what you are talking about. See here. This, when you have difference, it becomes this. When you do not have difference, it is just YT. When you have difference, you have to say YT minus 1. You have to say this. I know it is not easy. That's why I said, put ARIMA methodology on your resume will make you stand out. Because it is not easy. Many people, when they study the ARIMA, they quit. They just cannot comprehend it. And you are here to study it. Good for you. Keep on the great job. Okay. I love your questions. Please ask questions. Okay. And make sure you understand everything I talked about here. Those start from AR1, ME, M1, etc. So I'm going to write down here because they are in the same page. What is the model for this one? It should be YT minus 1 equal to mu minus omega 1 epsilon t minus 1 plus epsilon t. So this is for this. ARIMA 011. And this table right in front of you is very important. You have any doubt, you ask me or email me. Okay. All right. So this is a example 9.4. We haven't started. So this is a 9.4. So in 9.4, we propose two methods. Okay. One is MA2, the other is AR1. But before we do those methods, let's explore data pattern for 9.4. This time, I am going to go fast because we did this before. For example, how to create the line chart, go to forecast, go to sequence chart, and move into variable box, click OK button. So you get this data pattern. Okay. So as you can see, this data is pretty stable. It is a stationary data. It does not trending up or trending down. That's the reason we do not do difference for this data. Okay, no difference. Okay, next, let's explore autocorrelation. Again, I'm going to go fast. Analyze forecasting and then autocorrelation. So move this into variable. We need autocorrelation. We need partial autocorrelation. Okay, and from this graph, you can see there is a significant autocorrelation for the first leg and for the second time leg. Leg 1, leg 2 are significant because they are above the limit. Okay, and here the partial autocorrelation, the first one is significant. The first one is significant. Okay. All right. I created a video. That video will served as, remember next week, we have a test. After test, we do not have live lecture. Instead, we have online lecture. I pre-recorded video about theoretical model. Theoretical model. What is the theoretical model? So check out that video. It is explained. How do you choose model based on the autocorrelation function? Okay, autocorrelation function. So now go back to our example 9.4. Our autocorrelation indicate significance for time lag 1 and lag 2. Okay, so we finished our data exploration. Next, let's set up the model for 9.4. We propose 2 models. One is MA2 model. We use omega, okay? MA2, we use see this omega. All the coefficients, we use omega and we use mu. That is MA. Then we propose AR model. For AR model, we use phi 0, phi 1, phi 2, etc. Okay, so let's do MA2 first. Again, I'm going to go fast. After this example, we will take a break. Okay, so do MA2. Go analyze, forecasting, traditional model, and then move into dependent. We propose MA2 criteria, MA2. So this is my MA2 model. And statistic, I want to display forecast. I want parameter for estimate. Plots, check out these two, save, predicted value, options. Options, I need to see the forecast. Which forecast I want to see? The given data. Let me see. How many data is original data? So I want to forecast for 76 because the given data have 75 cases. Okay, so 76. And I click OK button. Okay, so this is my ARIMA 002. It is the same as MA2. ARIMA 002 is the same as MA2. And this is the model fit telling you what is the mean value for different measurements. Okay, the model, the general model statistics is here. Looks like a good model because we have this. If we actually hope L dream box Q, the thing is not significant. That is the good module. Okay. And for the ARIMA module, we have constant. This constant, remember, it is our mu, population mean mu. Okay, and then because it is MA, the coefficient we use omega 1, 0.558, omega 2, -0.347. Okay, based on these 3 numbers, we can write down an equation or model. And then the residue autocorrelation as well as the partial autocorrelation are very good. They're both within the limit. Okay, and then our forecasted value for 76 is 80. Okay, so this is this model. Now let's go my analysis here. This is the output. Okay, I need those numbers to write down the equation. All right, so how do you write down the equation based on this number? And remember, what is this model again? It is MA2. MA2 is the same as ARIMA 002. So what is the general format for MA2? Remember, I write this many times. I don't mind writing it again. YT equal to mu minus omega 1 epsilon t minus 1 minus omega 2 epsilon t minus 2 plus error term epsilon t. Okay, when you do forecast, epsilon t equal to 0. Okay, so epsilon t equal to 0. So now let's forecast for 76. So y hat 76 equal to mu. Mu equal to 75 omega 1 0.558 omega 2 negative 0.347. So equal to mu 75.407 minus omega 1.558 times omega t minus 1 means omega 75 minus omega 2. Omega 2 is negative, right? So minus negative equal to plus positive 0.347 times. When we do forecast, we use E, not epsilon. E75, E74. Okay, E75, E74. And then how do you know what is E75, E74? Go back to your data. So we need E75, 74. So E75 equal to 72 minus 64.4. Okay, and the result is 7.65. So E75 equal to 7.65. Now, what is E74? E74, you use 99 minus 71.9, and the result is 27.08. That is E74. Okay, plug in those E number into this equation and just do subtraction, addition. So E75, it is 7.65 plus 0.347 times E74 is 27.08. So the final result based on manual calculation, I got 80.538. What is the computer got? What is the forecast from computer? From computer, it is here. The computer gave 80.5. So it is match my hand calculation based on equation. See, this is computer gave. Okay. So that is MA2 model. MA2 model. Now let's create AR1 model. Remember this example, we want 2 models. Okay. So next, let's create AR1. So again, I'm going to go fast. Okay. So the procedure is here. Maybe I will just directly jump to. Okay, I'll go fast. So what I'm going to do now, AR1 model, AR1. So I'm going to delete this. So I'm going to do AR1 model. Analyze forecasting, traditional model. Okay. Variables, ARIMA criteria. I'm going to do AR1. So this is a 0 and the first one is 1. So this is AR1. Continue, statistics, okay, plot, okay, save, okay, options, everything is fine, okay. So this is my output, okay. So looking at this 2 diagram, fantastic, looks like great, okay. So the predicted value for 76 is 77.1. Where is my model? The model is based on these 2 numbers. But remember what I said before? When you do AR model, you have to do a calculation to get the real true constant. So I try to. is this is MA 705. So I want, this is the next example, 74. 75. Okay, I will just copy the result here. So our result will based on this. Okay, so I'm just going to copy. And then try to see. Try to locate that. This is MA2 we just did. Okay, so MA2. And then this is example 4. This is AR1. So I'm just going to put the result here. There is a space here, paste. No, that is what. That confused my original slide. Okay, I will just maybe use a little space here to handwrite something here. So when we propose AR1 model for example 9.4, we got constant from SPSS output, we got constant 75.326. We get AR lag 1 negative 0.531. Right? And remember, you have to do, this is AR, you have to do a calculation to calculate the real constant phase 0. The real constant phase 0 equal to 75.326 times bracket 1 minus AR lag 1, okay? Minus negative number equal to plus 0.531. And this number will give you 115.845. This is your constant phase 0, okay? And then your model would becomes, your model is YT equal to phi 0 plus phi 1 y minus t. So YT equal to 115.843. Phi 0 is negative 0.531. This is your model and plus error term. When you do forecast, error term goes to 0. Okay, so this is a AR1 model. Okay. Any questions? So in example 9.4, we proposed 2 models. One is a MA2 model, the other is AR1 model. Okay. Okay, questions? All right, shall we take a break? Come back for more examples. So back at 8:40. Okay, I'm going to stop recording.